So, um, with time, we have invented different tools to help us explore astronomy and explore the space. So, I'm just going to quickly review a few of them, um, and then you guys will get to use like a virtual tool um, that would help us in communicating where objects are in space. So, sundials allowed people to measure the passage of time by tracking the movement of the sun. So, sundials allowed us to track the movement of the sun and then keep track of time that way. I think you guys got to explore sundials a little bit more in grade 6. The Egyptians invented the meerkat. So the meerkat was an Egyptian timekeeping instrument used for telling time at night. So they use this to help them tell time. It says this star clock was extremely accurate and can be used to make astronomical observations. A quadrant. Now, we would have used something similar to this if we were in class, but a quadrant measures the height of a star above the horizon. So we're looking at the how high above it is in the horizon. So that would be its altitude, and we're going to talk about what altitude is. Okay, and then an astrolabe. So this is it's a version of a quadrant, but an astrolabe does exactly the same thing. So it locates, if you take a look at the bottom picture, it locates how high up, given an angle here, an object is in the sky. So again, we would have explored what an astrolabe is. You guys will get to just kind of do a virtual version of this. So we're going to look at 3 different components. You need 3 different components, and you need to know this. 3 different components to help you identify the location of an object in the sky. So the azimuth, which is usually what we would use a compass for, is the direction in degrees. So if you take a look here, the angle from north over to this line here, so this is my azimuth. So we would communicate that as 45 degrees, right? Because if this whole thing is 90, and this kind of looks like it's half, so it'd be anywhere between 45 to 50 degrees. So that would be our azimuth. So our azimuth is the direction. So the direction. So everyone could look north, and you could say, okay, now you're going to go, let's say, 100 degrees from north. And so if you're going to go 100 degrees east of north, and you're going to go 100 degrees this way, and you would end up here. So that's our azimuth. Okay. Our altitude is the angle above the horizon. So our altitude would be this angle right here. So if you look up, how many degrees did you have to look up in order to see this? So obviously, if you look straight up, that's a 90-degree altitude, right? So looking straight up is 90 degrees from the horizon, right? So from down here. So our altitude can be anywhere from 0 to 90 because no one's going to look backwards, right? So we would usually use an astrolabe to help us measure altitude. And then your zenith. So your zenith is the highest point directly above you. So just above here. That usually doesn't change. It's just right above you. And that's a 90-degree altitude. So this would be our zenith. Okay. So what you guys are going to get to do is you are going to do an activity. It's attached to your assignment or Google Classroom, where you are going to help you use azimuth, altitude, to help you identify where the location of an object is in the sky. And you guys are going to have to come up with some hypothetical answers, but you do need both to identify them because you need to know where, so which direction do you need to look? So do I need to look east? Do I need to look west? And then how many degrees up? Do I need to look 50 degrees up? Do I need to look 60 degrees up? So you do need both. If I just looked up 60 degrees and I didn't know what direction to look, I wouldn't find my objects. Okay? So you are going to complete this activity describing the position of objects in space using azimuth, altitude, and zenith.